Okay, it's right before first hour, so you're gonna hear some stuff in the halls probably. I'm gonna change a little format here, make this a little quicker, so I don't have to like upload my phone video. The drama club is making flyers using paper in orange, purple, navy, and beige. Okay, 4 different colors. They have markers in 3 different colors, and each flyer uses one paper color in two different marker colors. So how many distinct flyers can they have? So here, we're not doing a permutation. The order doesn't matter. The combination doesn't matter because you've got different objects, right? You're not choosing from the same pool of things. This is what's called the fundamental counting principle, where you're literally kind of counting how many choices you have for the one paper color, and then you're going to have 2 different marker colors. So if you have 3 marker colors for your first choice, you can only have 2 in your second choice. All right, so that ends up being 4 times 3 times 2, which is 24. So there's 24 different ways that you can get a one paper color and 2 different marker colors. So the English is so important when you're dealing with probability. That one word changes it from 3 to 2. Okay, so that would have actually been 36 instead of 24 if they would have been 2 of the same markers. But that's actually physically impossible. What is the probability that a randomly selected day in a leap year is not in the months of April, May, or June? Okay, so it is not in the monthly. So let's figure out how many days are in April. There are 30 days in April. There are 31 days in May, and there are 30 days in June. That adds up to 91. Okay, so what we're going to do is we're going to take 366, because it's a leap year, minus 91, and we're going to put that over 366. Okay, so there's 91 days that it is not. So let's do 366 minus 91 is that. Now that's a lot. It's a lot of the year, okay? And if you divided that, that's about 3/4, right? So just a little bit more than a quarter, which makes sense. You are dealing with 3 months out of the year, and if you don't want those, you want the other 75%. But it's just a slightly higher possibly because we're short we're short a day. Okay, there's only 30 days, and we do have a leap year, which includes an extra day that it is not. So that accounts for that little extra 0.0013 at the end of 0.75. Okay. A manager has 6 labeled folders and 6 different reports to file. If she randomly places each report in a folder, what is the probability that every report ends up in the correct folder? Okay. So this means that if you want to put them in the right slot, all right? So don't just multiply these 2 together. You got to think about this, okay? How many possibilities does this guy have to go into the right folder? He's got a 1 in 6 chance, right? So 1 in 6 chance that he ends up in the correct first folder, okay? Now, you got 5 left. You got 5 reports. What's the probability that one of those reports is going to go into the right folder? It's 1 in 5. Okay, you can see where this is going. Then the next one, you got a 1 in 4. You got a 1 in 3. You got a 50-50 chance right there at the second to last, and then you don't have a choice. You have to put it in that last folder. So right there, multiply this, and you're going to get, let me write this over here, okay, 1 over 6 factorial. That's exactly what we got here. So what is 6 factorial? Let's go ahead and do that. You could have just multiplied this out. Let's do 6, go to math, probability, and 1 out of 720. So you can leave it like that. Or you could do, it's going to be very small. It's going to be, less than 1%. So 0.00138 looks like it's repeating. Or you could have said 0.138%. Okay, you could have moved the decimal place over 2, and you would have gotten a percent. So all 3 of these are perfectly reasonable answers. Okay. All right, 4-letter codes created with Spark. If the letters can be repeated. Okay, so that's different. That means I'm going to have 4 choices for the first letter. Okay, yeah. No, I'm sorry, 5. 5 choices. 5, and then you still have 5 for that one, 5 for that one, and 5 for that one. You can repeat it. So this is not a permutation. It is not a combination because it can be repeated. Okay, you're not using up objects. Okay, so this is really just 5 to the 4th power, and that's 65. And they just asked how many. I'm sorry, I said 65. 625. Okay, and that's that. A teacher wants to write a 6-question quiz from a set of 12 questions. How many different forms of the quiz can be made? It doesn't matter what order. So she's got a set of 12. She's only going to take 6, and it doesn't matter what order. So it's going to be a combination. So let's go math, probability, combination. We got 12, and we only want 6 of those. So it's going to be 924. All right, now here's just a straight up evaluation. You've got 8 factorial divided by 3 factorial and 5 factorial. Now I want to kind of do this by hand just because it's cool. So if I did 8 times 7 times 6 times, you can punch this into the calculator though. Okay, and then 5 factorial, those guys actually cancel out. And then 3 factorial is actually 6, so that cancels out. You're left with 56. Okay, and you can verify that in the calculator. Just be careful, but you should get 56. Let's do 2 more here. There are 20 students in the golf frisbee club. How many different ways can 4 officers be selected? Looks like the order does not count, so we're going to do 20, choose 4, and let's go to math. Get that number. 20, choose 4. There are 4,845 ways. Now, these large numbers always fascinate me because it just seems like, wow. But there are 20 students to choose from. So, yeah, that makes sense. How many tennis matches can be played in a tournament with 9 players of each person plays every one twice? So this is a little different. This is a combination. You got 9 players, okay, and you're going to do that twice, okay? So first match, second match, okay? So let's just figure out what combination is here. 9, choose 2. That's 36. So we're going to get 36 combinations for the first match. And then you got 36 combinations for the second. So 36 squared is 1,296. All right.